Good morning, good afternoon, good evening for all the participants across the globe. I would like to congratulate all the organizing committee and sponsors and the volunteers for organizing such a first ever global summit. It's fantastic so far. And personally, Yarik, thank you very much for being active participant on our Airflow Slack community. Sincere gratitude to you. So, as you mentioned, I work as lead data engineer at PlayStation. So, uh, the presentation title, Airflow, a beast character in the gaming world, might ignite a little interest in your mind. What exactly the beast character means, right? So, in the gaming world, character plays a vital role, and a lot of people becomes fans, millions of fans for character in the gaming world. So, but behind the scenes, Airflow is one of the tools which is widely being used across the gaming industry. Some of the fellow Airflow engineers have presented talks from Electronics Arts in this summit, and some of them from other gaming companies. That itself indicates that how vastly we use Airflow in the gaming world. But my intent here is to present how we horizontally scaled our Airflow on AWS ECS. So let's get on to the presentation, and I want to make it simple and informative. The agenda is pretty simple. I'll talk about the story and the problem statement and what all the different options we have, solutions we have explored, and what solution we have picked which suited well for us, and then little over discussion about our learnings and Q&A. So let's talk about the story. At PlayStation, we have multiple data engineering teams, one for sales, one for content engineering, one for marketing, and also we have a big centric data warehousing team called Data Ocean. But I'm part of the content engineering team. So a little over a year ago, so we got a chance to create a brand new data engineering team for our content engineering team. So as it is new, we got an opportunity to explore what are the different options available in the market, what are the cutting edge practices that industry is following in creating the data engineering frameworks or the data pipeline orchestration. We picked Airflow for obvious reasons. That is why we are all here. We know how powerful Airflow is. So, like many of us, we started very small with Airflow. We got the Docker image, we put it on AWS EC2, and then we started creating multiple DAGs and multiple proof of concepts to see how exactly it is working. Everything is fine. And then we started creating the data pipelines. We sourcing data from multiple sources within the organization from different transactional systems, doing some ETL work on the Apache Spark, and then provisioning the data in our persisting the data in our data lake powered by Athena and AWS S3. So this is the architecture we have. It's pretty simple and straightforward. We have the AWS EC2, and as you guys know, I assume that you all guys know the fundamentals and the basic information of Airflow. We have the web server, scheduler, Celery, Redis, and Postgres and Worker. These are all the main services that run. So we have our architecture before scaling in this way. Like one worker is supporting and one scheduler. By default, when the worker will come up with certain number of their concurrency, worker concurrence, and all sort of, which I'll talk about it later. But as this is the before scaling architecture, we had a problem statement to define here, which gave us an opportunity to scale the Airflow horizontally. So the number of DAGs and the number of tasks to run parallel are exponentially increasing. Why? Because there is a number of increase in the DAGs as we continue to onboard more number of data sources within our ETL pipelines. That is a usual practice in any data engineering world. We try to source more data, we try to onboard more data sources and try to build ETLs, create an integrated layer, come up with a beautiful analytics and insights out of the data for the organizational effectiveness. That is quite obvious, right? And the other one is increase in the number of environments. We started with the development environment and production environment, but in order to have a robust testing and other system testing and other best practices in the development lifecycle. We created system integration testing and pre-prod environment. These are all different environments also we have onboarded. But in order to make it ease of maintaining our airflow, we have only two airflows. One is airflow non-production and airflow production. In the airflow non-production, we handle all the DAGs, part of development and system integration and pre-prod as well, which is kind of tripled all our DAG numbers and the number of tasks in our pre-prod environment, in the non-prod environment. So that is one reason why we have an exponential increase in our tasks and DAGs to run. And also there is another important concept called provisioning data. Once we create the integrated layer of the data, but in order to share this data to our downstream data users, we have data contract with them. We cannot share every data to everyone. Some of them are first party partners, some of them are third party partners, and based on the data contract what we have with them, we have to expose certain number of data elements to them. So this is one framework we have created on Airflow, which kind of gives a dynamic way of provisioning the data based on the data contract and the rules that what we have. So that is one reason which is contributing a lot of DAGs and tasks on the Airflow. And here is the bottleneck. As the number of DAGs and tasks are increasing, and it kind of, if the maximum parallelism or maximum worker DAG concurrencies are being set to a particular limit, it cannot handle more than that. Either you have to increase that, or else you have to find out the opportunities how to handle it, right? So more number of tasks are getting queued in the Airflow because the worker default concurrency is about 16. And also it's adding a latency in the data arrival into the data lake, because as more number of tasks are in queue, it will take time to complete all the tasks to refresh the data from the source systems into the target systems, right? And also if you add a lot of load onto the Airflow, you always have to keep in mind that whether the infrastructure that we are using to configure Airflow is really good enough to support this much load or not. So these are the points which immediately took us a decision, made us to take a decision on how we want to scale our Airflow. So when we are talking about scaling, you have two options. One is vertical scaling and the other one is horizontal scaling. And I'm not here to talk about which one is better and which one is not, but every scaling technique has its own advantages and disadvantages. But we picked up horizontal scaling because there is no downtime involved, and also though it's a little complex to architect, but still we prefer that because we continuously see growing our Airflow, more number of DAGs, more number of data processing pipelines that we want to onboard. So rather than going vertical and keeping as a one single point of failure, we prefer to have horizontal scaling. So when we decided to do the horizontal scaling of Airflow, so what are the different options we explored? So containerization is one of the best approach framework for scaling our applications, right? So we tried exploring Docker Swarm. Docker Swarm is nothing but a hub of Docker instances, and one Docker instance work as a master, and other workers as other Docker instances work as slaves. And in that hub, they can able to distribute the work among themselves. And Kubernetes, of course, one of the most popular tools, frameworks. Um, we explored that option as well, which is great. As I said earlier, I cannot say which is great and which is not great. Every framework has its own powerful capabilities. But out of all, we have chosen AWS ECS because of two reasons. One, the current application which is already running on EC2, all that we want to do is just to containerize it without making any code changes. For example, if I use the Kubernetes in order to utilize the best out of it, I have to use the QPod operator in our Airflow, and that may lead to a little bit of code changes for us to create the DAGs for utilizing the pod operators and all. But in order to minimize the code changes, almost no code changes, and we just want to scale our application. And also, as we all have pretty good idea on how the orchestration is being done on EC2, so similarly, we'll follow the same route on ECS as well. So for transition perspective, it is very easy for us as well. So those are the two main reasons we opted for AWS ECS as an option for our Elastic Container solutions. Now let's talk about airflow tuning a bit. So most of you guys might have know this topic already. If not, I strongly recommend you guys to go to the source on Astronomer, one of our sponsors of this event as well. They've written a very nice blog about scaling airflow and different topics involved around it. So I would like to give a very brief overview on these topics. Parallelism, in simple words, across all your airflows, across all the DAGs, how many tasks you can run in parallel is nothing but a parallelism. When it comes to DAG concurrency, within a DAG, how many tasks you can allow to run. And when it comes to worker concurrency, for each worker, how many tasks it can handle at once. So these are the three main terms. By default, when you download the Airflow image from the GitHub and try configuring, generally it goes this way. The core parallelism is set to 32, and the DAG concurrency is set to 16, and the worker concurrency is set to 16. Here, 1 multiplied by 16, meaning to say one worker, which has 16 tasks as the maximum allowable concurrency. But we tried scaling, and after scaling, the numbers are like this, and I'll walk you guys through how we tried scaling it, right? So the thing that we have taken a call is to increase the number of workers and increase the size of our scheduler to handle that load, and also increase the worker concurrency from 16 to 24 so that we can achieve about 96 worker concurrency here, right? So now, as I was discussing about the architecture before scaling, now what we have decided is to convert the EC2 Docker powered Airflow to ECS Docker powered. So what I'll try to visually present here is, first I would like to uh, delete the EC2 instance and replace with the ECS instance. And then you have all the other services as it were, like Celery, web server, scheduler, Redis, and worker one. And now I will add one worker here, worker one and worker two and worker three and worker four. So this is what our after scaling architecture look like. So just to go a little overview, so from computers to the internet gateway, we have one VPC on our AWS network, and which is connected to a load balancer powered by ECS. ECS is nothing but a container service, which is a hub of different container EC2 instances, and each instance will handle different services here. So this is our after scaling architecture. So now let's talk about ECS a little more so that I can easily help you guys understand how exactly we tried converting a single tier application into a multi-tier application kind of, right? So introduction to AWS ECS. I strongly recommend you guys to go to the AWS documentation, read more about it. But on a very high level, it's an Elastic Container Service, and task definitions and Docker containers are a few of the critical components part of the orchestration, and services also. So first we create the task definition, and then we create the services. Once the services are up and running, and you will be having a smooth airflow application. For example, if you see on the side diagram, you see this icon represents the ECS container and also ECS cluster, and the dashed lines indicates different container instances, and in each container instances we have different tasks defined. Each task will be entitled to a specific Docker container, and that Docker container can do serves for a purpose. Either it's a Redis hoster, or it can host and Postgres, or it can host a web server and whatnot, right? So this is on a very high level. You think like it's a cluster of EC2 instances, and that EC2 instances powered by Docker, and it will be easily able to create containers within it, and each container can able to handle different airflow services for us. Now, the other important thing is you all guys might have seen this Docker Compose YAML file. This is one of the very key file for our airflow orchestration. While we are setting up the airflow, you will have to create this Docker Compose YAML file and define the service definitions here. So you have Redis, you have Postgres, you have web server, you have Flower, you have scheduler, you have worker, and different definitions. You might have already seen it, but let's go to one of the service definition here, which is a web server. So if you take a closer look at it, so what all the different kind of components or the attributes that we are trying to define here. One is image, where exactly our Docker image is being stored, and also what all the dependencies it has, right? So first we'll give the name of the service, and we create the image where exactly the image is, and also we give the environment variables which are needed for this particular service, and then we define the volumes directory where we can put our DAGs for the continuous integration, and also we define what ports these services are enabled on. For example, for web server, it 8080, and what is the Docker command that we're going to use in order to spin up this service or spin down the service, and which is a web server, right? Why I was trying to put here as a key attribute, because the way we're going to orchestrate, or the way we are going to convert this EC2 powered airflow to an ECS powered airflow, is that we are indirectly converting this YAML file into multiple pieces, and each pieces we're gonna entitle to a different service on the ECS. So this diagram gives you a better idea. So in the existing architecture, you have the EC2 with a Docker Compose YAML file. Now let's assume that you split that Docker Compose YAML file into 6 different subfiles. One is Redis YAML and Postgres, Docker Web Server, Airflow Web Server YAML, and Celery YAML. Likewise, you think like you virtually segregated that YAML file into 6 different parts, and each part again we are trying to attach to the ECS container. This ECS container is nothing but a container within the EC2 which is under the ECS. So if you see the diagram, we have a big ECS cluster here, under which you have different EC2s here, and under each EC2 as a dashed lines we have different containers here. And you may have a question here, like you can use one EC2 for each container, but for Redis and Postgres on the web server and Celery, we don't need an dedicated EC2 instance for them, because if you take web server, it's more or less for the user interface to interact with Airflow, to see the Airflow tasks and statuses of the DAGs and all sort of. But the original work is being done by workers and the scheduler. Scheduler takes up the complete load to schedule and organize the complete workflows, whereas the workers are the real soldiers who does it. So who does the work? So because of that reason, if you see, I have intelligently tried splitting the containers and grouped into different groups, so that we are not onboarding more EC2 instances just for nothing, no reason, right? So I encapsulated both ECS containers for Redis and Postgres into one EC2 instance, and the web server and Celery into another EC2 instance. Scheduler, just one standalone EC2 instance. For worker, if you see, there are 4 different containers. This worker is being replicated on 4 different containers, and 2 containers per each EC2 instance. So about 5 EC2 instances under one elastic container services cluster, which is kind of giving us the power to horizontally scale our application. So At a very high level, the Airflow ECS way is nothing but the single Docker Compose YAML. You try splitting it and try attributing that each individual service to the containers on the ECS, right? Now, I just would like to give you a little bit overview on how exactly these tasks have been defined in our Airflow. There are two ways you can do it. One, you create you create a cloud formation template where you define all the parameters, or else you go through the AWS console and navigate through the ECS cluster and then try creating all the task definitions and services and all. Here I have masked some of the attributes which we do not want to expose as it belongs to my company. So I masked it. Most of the confidential information are the identifiers there. But when you log into your AWS portal and once you uh, check for the ECS service, you will be seeing the left side panel like clusters, task definitions, and account settings and all. So you go to the task definition and create all the tasks required. So if you, as I mentioned in my previous diagram, I have total 9 different containers holding 6 different services here. So if you see the tasks, first I'll create all the 9 task definitions here. Once I have the task definition, I have to attach the related container instance as well. So that is nothing but when you are defining the task, so it gives an opportunity to add the container here. When you are clicking on the container definition, you see the container name and the container image and the container port mapping, and also you see the command that you give, and also the environment variables that we're going to set up for this particular container. If you remember, 2 3 slides behind, so when I was explaining the when I was trying to explain this particular slide, I was giving these are the key attributes to take a note down part of each service. So this is nothing but you are defining these values part of the container definition here, right? So once you have all these container definitions completed, and then you will create a service on top of it. So for each service, you will have the desired tasks and the number of tasks that are running here, right? So for a flower, we need only one instance to run. For worker, we want 4, so that is the reason I have put the desired task to 4, and the running task right now is 4, whereas all the other ones I gave 1 1 1. And one thing I really would like to emphasize here is that when you are creating a container or attaching a container instance for scheduler, keep it bigger, so that your scheduler will not get overkill. It will be able to handle the parallelism there. So while you're defining, you also give these CPU units as well as the memory that you're going to use. These are a little bit of mathematical calculations. You try analyzing our application load and how big the cluster needs to be and what memory you need, and all these pre-calculations you do in a paper, and then try uh, uh, try and rough orchestration diagram, like this is how we want, and this is how we would like to distribute the resources of our EC2 instances under the ECS across the Airflow, and then orchestrate the solution. So once it's done, then uh, it's pretty much simple. Like, the way you are working on the single EC2 Airflow is quite similar to the Airflow horizontal scaling. For developer, he doesn't even know what is the difference is, because he always accesses the Airflow UI. But the DevOps engineer or the infrastructure engineer in the backend is the one who maintains this. Is also simple. It's not very complicated or as sort of. The ECS has the command line CLI tool enabled, where you can trigger the commands right from your terminal, and then you try spinning up the application, spinning down the application, and recreating the image, attaching the image and all. Now here, one interesting point I would like to mention. There are some issues encountered while we are doing so. One issue is Airflow metadata database may run into exceeded max number of connections error. This is because once you increase the DAG concurrency and worker concurrency, what happens is your more number of tasks part of your Airflow DAG starts running in parallel, and each task will, for example, each task is to connect to a data source and brings the data. So it'll connect to the database and then enables a connection and tries draw the data from the sources, right? So you have to intelligently choose a RDS instance or the database instance which supports this level of maximum connections. And the other one is like you try keeping all the AWS components under one VPC so that the permissions and so in simple words, when we orchestrate the Airflow solution, which is nothing but you are spinning up multiple services like web server, scheduler, worker, and salary, and these all needs to talk to each other in order to have the proper Airflow running functionally, right? So if you keep all these components under one VPC and one subnet, and also give the security group attach it to all these AWS components as one standalone, what happens is they can easily communicate with each other. You need not to do a lot of routing and network and port mappings and all sort of things. You can avoid. And sometimes the services fail health checks because the health checks codes are not a very standard health checks that we're gonna get like 200 error or so. So you try checking for what the health check code that is being coming, and try configuring your service in line with the health check codes that Airflow is giving up. And also, the other issue we encountered is the inbound and outbound traffic for all the RDS instances and the ports defined. So rather than using Postgres, we decided to use an Airflow metadata database, which is on AWS RDS on MySQL, so that we can start running different queries on Airflow metadata and then try understanding, uh, getting some kind of statistics out of our Airflow metadata, and also to run a daily status report or daily audit checks, like when these jobs ran the for last time, when the data pipelines have been refreshed lately, these kind of reports that we can generate out of the Airflow metadata. So that is one reason we decided to keep an external Airflow metadata database rather than the Postgres. And the other thing is choose the EC2 instances size very wisely and architect the solutions for the maximum utilization. If you choose an instance, you have to choose the type of the instance which allows multi containerization feasibility. Some instances won't allow you to create more than one container. Some instances won't allow you to create more than three containers, so on. So depending upon what exactly the solution that you want to build, based on the architecture, you have to intelligently choose the EC2 instance. This is all about I would like to discuss today. I wish I walk you guys through the core and more screens to give you guys a better idea about how exactly we are done. But due to certain security constraints, I cannot able to share the screenshots, or cannot share the application with you guys. But as I mentioned, if you are new to Airflow, and if you are trying, you are in a position that you are hitting the performance bottlenecks, if you want to increase or the scale your application, then if you are already on Amazon AWS cloud architecture, then ECS is one of the preferred ways where you can switch to a horizontal scaling at a very quickly. Is something I would like to suggest you guys. And many of you guys might have already done this, or some of you guys are in process of creating this, but feel free to let me know your learnings and share it across, so that we all can build more robust and good solutions for our organizations. Yep. This is all about I would like to talk. Yep.
Good. So time for question and answers. So right now you can ask questions both on Crowdcast as well as in our Slack channel. And while waiting for the questions to appear, I would like to thank you for the presentation. It was great. It was fantastic.
Thank
Uh,
you.
when I was doing my presentation about production Docker image, I mentioned very briefly like one slide about possible deployments and like Docker Compose, container service like ECS, and then Kubernetes. So those were the three. And of course, I had no time to talk about that, but you talked about that in great detail, I think.
Cool. Thank you.
And I have one question
Hmm.
related to your presentation to start. So first of all, I noticed that. So you mentioned you have the Docker Compose initially, and then you have the images. And
Hmm.
I noticed that there was a Pukel image you were using as a base
Exactly.
of
Yeah. Correct.
your installation.
Hmm.
Uh, so my question is like we are at the stage now that we are switching to the official image, and
Hmm.
we are also thinking as a next step to add a kind of officially supported Docker image to that,
Hmm.
supported by community. So that's the important thing. And my question is like, is there anything to that prevents you from switching to it? Are you planning to do that? And if there are some things that you would like to have, if you could tell what is needed by those two for you to run.
Sure. So that's a great question. and and if at all any image that is officially supported from Airflow community, that's great because that's what we all need, right? So right now we are using the Purple image because that is the most popular one, as you know, so far. But we are closely following the Airflow releases. Whenever the upgrade happens, and we immediately reading what the upgrade is about and how it is going to add value to our tool right now, our framework right now, and increasing our Airflow versions accordingly, upgrading our Airflow versions accordingly. Definitely, we would like to utilize the official image. There is nothing which is really preventing us, and I'm pretty sure that when you guys are creating, the expert brains are creating that image, you will be keeping much more use cases in mind to come up with a solution. So obviously, that's a single point of contact kind of for every Airflow developer across the community, which will be great, like standard one. So we do not have any such limitation. We are happy and open for adopting that.
Okay, good. That's great news, and I'm happy that this is gonna happen. Like I hope for better adoption or starting adoption because we just started releasing it, and literally last week was kind of version that was ready for use for production use and still is going to be improved. There are some questions. The
Sure.
first question is like, how many people are working on your team?
Okay. So we have about 15 people team spread across US and UK for the data engineering. Our data engineering team name is Hiraku, meaning to open for opportunities. Hiraku is a Japanese word. As you know, PlayStation is a Japanese based company. So right now, the data engineering core Airflow team is based off Los Angeles, California. We are here about 5 people who are working on the data pipeline orchestration. The remaining all other folks right now are focusing on the data migration applications. But all in all, our Hiraku team is about 15 people team at this point of time.
Okay, good. That was the second. There is a second question.
Mhm.
What is the max parallel tasks you run on such a configuration, and what max connection you use on RDSDB?
Okay, so right now we are using 300 as the maximum connections on RDS, and we are using a maximum parallelism so far, like 96. To give you a little bit more insights about that, when I was talking about the provision consumer, as we were trying to provision the data to all the downstream users, and our downstream users are from different departments within the PlayStation, and some of them are the third party data consumers as well, development partners as well. So when we try to provision the data, what we try doing it, rather than doing a sequential way of provisioning each table, we try to provision all the data sets together to them. So that enables us to create a multiple views, multiple tables at once, powered by our Apache Spark application in Python Spark. So that PySpark, more number of tasks run in parallel. So we have almost 250 tasks to run in parallel for all the downstream consumers we have at this point of time. So even if we want to scale the 96 number to much bigger, still it will be useful for us. But we are at this point of time tried finding out a, break-even point, kind of balancing point, like not adding more latency at the same time, not adding more AWS cost. We tried keeping it at 96 level. At peak times, we are utilizing that 96 parallelism at this
Mhm.
point.
Is there just there are a few more questions, but maybe I introduce mine because I'm also interested. So, is there
Yeah.
any way to manage auto scaling capabilities in the cluster, or do you have to manage it all by
No,
yourself?
it's pretty simple. As I mentioned in one of my slides, where the workers, all that we are doing here is um, Airflow, all the services are as it is, only the scheduler instance which are making bigger, and the worker instances we are onboarding more so that it can share the load, right? So these are all attached to a load balancer. So if you say to the load balance to spin up the services from 4 to 6, then it will immediately get one more EC2 instance and creates two containers and two workers and attached to our ECS. And that ECS will be automatically attached to the scheduler. So auto scaling is at a single trigger point. Um, Manual process at this point of time, meaning to say you just need to give a command that scale up to 9 workers or 10 workers. It will just do by itself. You need not to do, but it is not going to spin more worker instances by itself by understanding the airflow load at this point of time. But if we acknowledge that our airflow need more workers, it's just one single command to get that. Yeah.
Yeah. Okay. Yeah. Yeah. I thought more about like kind of some algorithms to scale it automatically, but I understand this is next stage maybe.
Yeah, maybe next stage.
But it's
Definitely,
like
that
it's
is
ready for that. It's similar like
definitely in our to-do list. Definitely.
you take a look at the Kida autoscaler because it works fairly much the same. Like kind of like it uses the existing autoscaling or scaling capability of Kubernetes cluster, and
Okay.
it runs some queries. You can run some queries on the database and see how many processes are running, and then scale your ECS cluster
Mhm.
automatically as well. So you might take something from that. Uh, Another question: what was the most challenging issue you faced while transitioning to after-scale architecture?
So most challenging issue we found is the network area, like the VPCs, and when we spin up more number of EC2 instances and how to bring them under one umbrella and how to enable the communication between those services. It's like a big learning process for us. This is not an overnight process that could be able to scale the application. It was a continual learning. We were exploring multiple options like Kubernetes and ECS and also the Docker Swarm and all. And part of those learnings, we all took about multiple weeks, and then we came to a stable point that yes, this solution is what is going to work. So as I mentioned, many of the guys who want to try this approach, the key thing that you needs to keep in mind is how we intelligently convert the Docker Compose YAML file in line with the AWS ECS way and try attaching those to the containers is one key area where you may miss, and where there is no lot of documentation available on the internet as well. That is one thing. And the other thing is, while you are adding containers within ECS EC2 container instance, and each container each instance is different type and it has its own infrastructure limitations, whether to add more containers allowable to more subnets, so these kind of network things which won't give you the clue why the service is not up and running, but you'll have to brainstorm troubleshoot a lot to find out, like what might be the root cause. And in some cases we ended up like supporting we ended up going through the CloudWatch logs and check what all the error codes that is throwing, take some help from the community and the internet and try understanding how we solve it. And that is how so to answer the question simple, like the infrastructure wise is one challenging part, and the other challenging part is the configuration of YAML into the ECS. So unless until you are very familiar with the containerized orchestration, you will not be able to get it in one single shot. You may need to have multiple tries.
So, but the gist of it is also that the community is very helpful. Yeah,
Yeah, yeah,
when you have problems.
yep,
So
yep,
that's an important learning, I think.
yeah.
Another question is: have you considered PG Bouncer that does intelligent connection pooling to alleviate the connection issues with RDS? There was a talk earlier in the summit that explored this as well, and I think there were like 3 or 4 talks talking about that.
Exactly. So that is one of the to-do list for us, because after closely following the Airflow Summit, there is one main reason for Airflow attending and participating in Airflow Summit is not just to share our learnings to the community, but also to learn from the community. So there are a lot of talks, and which created a lot of action items for us to enhance our infrastructure. Definitely, we will be utilizing, yeah, whatever the maximum possibility of automation we want to do, at the same time which is stable and more reliable. Definitely we're gonna adopt those in our infrastructure.
Okay, that's perfect. So another one: have how you're connecting multiple AWS ECS services and how many task definition in each ECS service?
Okay, right. So to give you a little clear idea for, so the total number of services represents this particular YAML. Probably the Redis one, Postgres, web server, Celery, and scheduler and worker are the 4 services we have. And the tasks are total 9. Well, Redis we have one task definition, for Postgres one, for web server one, Celery Flower one, the scheduler one. But whereas for worker we have total 4 tasks defined. And when it comes to how we attach the services to the task definitions, the worker is attached with 4 task definitions of the worker. So if you see um, the slide here, these are all the services, and here it says what are the desired tasks that's been attached to each service. So this is how at this point of time our orchestration is.